All right, good morning, everyone. So this is electronics or ECE 12.1, electronic, so title na sa inyo, electronic circuits, devices, analysis. Okay, so as what I have said last time that we met, this will be sort of an exposure for you, EE students, to not only to electronic devices, electronic circuits and systems, but also to the field of ECE or to the field of electronics engineering. So, rightly so, that is our first topic for this semester, an introduction to electronics engineering field, introduction to electronics engineering, and electronic systems. Okay. So if I would ask you, itong mga present today karon, na mo idea ang sugid ang magkalahian sa among field, sa among kurso ECE sa inyo ha, EE. Do you have any idea? If you have, pwede lang ninyo i-type sa chat, no? Or pwede lang niyo open yung mic.
Mas gagmay niya, sir.
Gagmay, amuang. Okay, so pasabot nga gagmay, amuang mga voltahe, yan na, power, ang mga component, or sa ba?
Component, sir, sa sulod.
Component.
Devices,
right?
Niya, sir. So,
mga devices sa mua. Sa inyo, di ay, sa EE, so man di ay. Di ba ba may devices? Ha?
Kuryente, sir.
Kuryente?
Tigatag na may kuryente, sir.
So medyo oversimplification lang na siyang mga observations, no? Pero there are some truths to it man sa atong inyong giingon ug katong aton na isgutan karon lang yun. In a much smaller scale, in size, in some perspective, na parts ang field nga mas gagmay, mas smaller ang scale. Pero actually sa una, no, most probably sa una mas truer na siya kaysa karon. Pero karon technically dili na kay na siya mag-work na definition, no? Because of the emerging fields put in our emerging subfields in our field. Siguro I think ma-cover. So sige lang, I believe na naman tayong mga sub-notion sa differences between EE and ECE. So gamay lang at trivia, sa gawas, or siguro sa abroad, sa US, sa mga universities sa United States, usa naman ang ilang gina-enroll kung gusto sila mo padulong sa field of power systems engineering or electronics engineering or even computer engineering, no? Although na po yung mga some colleges nga offer na give na specific courses, the same sa Philippines, pero ang mga big universities sa US nga ang ilang kurso is kana lang yun, no, BSEE. So kung tanaw ni mong curriculum, valid, no, dili pareha sa curriculum nato dili sa Philippines nga ang EE katong yung mga the same sa inyong gingon, mga dagko ay gyud, no, dagko nga power ug dagko nga mga machines. Ang ilang curriculum dito sa BSEE is dili lang kay general, but kung imo tanawon malag na pagka-ECE, no, na pagka-ECE. Kibali specialization lang ang microelectronics or ang computer, no, engineering, or even ang power systems distribution. Ang mga students dito is mo enroll og BSEE, then ahit lang sila matawag og maybe electrical engineer gyud, in the same way pag-define nato dire, or electronics engineer or computer engineer kung mo-graduate na sila. Pero sa college ilang gitake is BSEE, no? So trivia lang na siya gamay because in some sense na po yung pagka-advantageous ang atong curriculum dito sa Philippines, at least defined siya, no? Kung yung kag BSEE is into power systems yun. Kung yung kag BSECE, electronics and microelectronics. Kung computer engineering, of course, into computers. Pero sa gawas, kanang tulo na subfields is BSE na siya. Anyway, kung ano na siya, no? Side comment lang. At least, we learn something new every day. So what is electronics engineering? So dagan mga definitions. If mag-search ta sa Google we'd come up most probably with millions of definitions of what is electronics engineering. Pero let's define it simply, no? Simple lang ito pagka-define para dili complicated. No? So electronics engineering is the analysis and the design. No? So what is kaning analysis and design medyo inverse functions isla of each other. Synonymous ang analysis to pag take apart, no? Taking things apart. Ang design is synonymous sa pag-combine or pag-synthesize, pag put together. So again, electronics engineering is the analysis, no? Taking things apart, not only physical things but also the concepts, the principles, the analysis and the design, no? The synthesis, the combination, not only of the devices but also the concepts and principles governing electronic devices, electronic circuits, integrated circuits, and electronic systems. So medyo na po na sila pagka-hierarchy. At the lower level are the devices. And then mas complex ang devices kabali, mas complex ang circuits kaysa sa devices, of course you know that. Then mas complex pag yun ang integrated circuits. And then we also have electronic systems, no? Which is siguro at the very top of the hierarchy of the things nga itong ma-encounter. Alright, so devices, circuits, integrated circuit systems. So what differentiates then, if akong reformulate ang question earlier, what differentiates then an electrical circuit, a purely electrical circuit, from an electronic circuit? You could say nga all electronic circuits are electrical circuits man. Yes, that's correct. But not all electrical circuits are electronic. No? So medyo subset siguro. No? Subset ang electronic circuits sa bigger group na electrical circuits. So dilitan na electrical circuits ka electronic. So what differentiates then an electronic circuit to that of an electrical circuit? So it is the presence of the electronic device. And I guess mas makover nato later in a much deeper na fashion ang electronic devices. So again what is electronics engineering? The analysis and design of electronic devices, circuits, and systems. But if we refer to the law, especially the law na govern sa field and the practice of electronics engineering in the Philippines, natay Republic Act for that, no? Sa amo ni siya professional practice RA 9292 or the taas mo kayong title the Electronics Engineering Law of 2004. So gidefine po by law sa Philippines what is electronics engineering, no? What is the lawful practice of electronics engineering? That's important, no? Important na siya para ma-distinguish good at least here what differentiates the scope of work of the ECE and that of other professionals. So nasa section 5, no? Taas kayo na eh. I'm not going to read this all, pero ikaw na lang, no? Skim na lang. Mubuo lagi tatong definition sa ECE ganina. Kanitaas-taas siya. The scope and nature of the practice of the ECE, the electronics engineer, shall embrace and consist of any work or activity relating to the application of engineering sciences and or principles, the investigation, analysis, synthesis, planning, design, specification, research and development, provision, procurement, marketing and sales, and so on and so forth. Ang technical support and maintenance, not only of circuits devices, but also the test, measurement, control, operation, repair, servicing, equipment, systems, network, operation, processes in the fields of ECE, including communications, ICT, computers, no? So, ang field di ay sa IT and computer, networking, computer systems is gibelong sa balaod sa law sa ECE, no? So that's interesting. Medyo wider kibali. If there's one thing atong makuhaan medyo wider ang scope sa practice sa ECE Philippines. No? At least sa panlantaw sa balaod or in the eyes of the law, mas wider ang scope. Of course, in actual, broad man yun, no? So, taas kayo siya nga definition on what is the nature and scope of practice of the ECE. Ako lang nagi layout because again, it's important for us to know what's the different in terms of practice ng mga guni, no? Medyo basig ma-model ba pag practicing engineers ata. Sa difference sa kinabuhat sa ECE ug sa other fields of engineering, not only EE but also computer engineers, so pa ba ang mga mechanical, no? Mechanical engineers, chemical engineers, and so this is what the law says on what our field is. So what are the more general subfields of ECE? Okay, so dagan pa, no? Most probably dili na ako comprehensively cover tanan nga mga specific fields sa ECE, but all the general ones, no? All the general ones and the more familiar ones atong makover karon. So we have the field of analog electronics. So analog electronics cover all the I think all the devices na itong most probably ma-encounter, no? Because those are more analog in nature. Okay, not only resistors, inductors, and capacitors, but also cover discrete diodes and transistors, which can be built to form amplifiers, oscillators, filters, timers, and so on and so forth. So if there's a field such as analog electronics, so may inverse sa analog, no? Or yung opposite, digital, no? So napoy field of digital electronics. Okay, isa po sa makapa-differentiate sa analog electronics o digital electronics, not only the presence of the discrete components sa analog electronic circuits, but sa signal, no? The type of signal na ilang process sa circuits and systems in these two fields. So analog electronics, of course, ang signal nga i-process are analog signal, no? The most common analog signal that we can encounter is the sinusoidal signal, no? Sine wave. So sa digital electronics, ang signals na i-process sa mga digital electronic circuits and systems are digital in nature, no? So gamay lang ni nga idea, dili pa man nato noon makover ang digital electronics good sa ECE 12.1. But digital signals are those discrete signals na ma-describe ang on and off na characteristics, no? So duha lang gid ka discrete states sa digital signals, on and off. So ones and zeros. Okay, 1 0 1 0. Kung ato natanawon sa oscilloscope, no? 1 0 1 0 0 1. Ana lang. No? Unlike sa analog signal, nga pwede sinusoidal or pwede random, any kind of random signal. basta kay continuous and continuous and analog in nature. Basta digital electronics kay on and off lagi na siya, ones and zeros. Under aning field actually ang the design of microprocessors and computers, no? So combinational gates, latches, flip-flops. Ay lang sa magka-worry unsa ni sila nga mga devices. Okay. This is just an introduction, no? At least ma-familiar lang sa term. So dili na siya mao ang coverage sa atong subject. We also have the field of microelectronics, nagani emerging field of nanoelectronics, which is more complicated na. But ang microelectronics, ang under-ani, most probably, pwede ka po na ito maingon nga combination niya sa na-overlap between microelectronics and katong earlier, analog and digital. But when you say microelectronics, under-ani ang integrated circuits, ICs, such as this one sa picture, no? These are what we call integrated circuits na nakamount sa motherboards nga atong easily ma-observe, no? Sa mga computers, sa mga gadgets, cellphones, atong ablihan atong cellphone, most probably kita nataog motherboard na nakamount dito ng mga mga ICs. Not only ICs but also MEMS or micro-electromechanical systems. No, sa sulod ani nga mga integrated circuits is naanay mga mechanical nga mga parts, no? There's such thing as that na. So not only microelectronic circuits, micro-electromechanical circuits, but also radio frequency circuits, no? RFICs. Kani, although the field of power electronics has existed taod-taod na, no? But kani nga field ang nakapaingon ta nga dili lang di ay into low power ang electronics engineering, because we now have power electronic devices that are capable of handling voltages up to 10 kilovolts and above pag ganina, no? Depende sa device. 10 kiloamperes, no? And tens to hundreds of kilowatts. No? So mga dinagko naman pud ni nga mga power, di ba? O voltages and currents. Nga usually ang ga-handle lang ani is mga electrical machines and electrical apparatuses, no? Apparatus. Pero nana po yung mga electronic devices na capable of handling these amounts of currents, voltages, and power. So we have high power electronic devices na. And the combination of those will be made into converters. DC to DC converter, DC to AC, AC to DC, AC to AC. Back converter, boost converters. Ang electronics nga, the next step after sa solar panel, no? So those are under the field of power electronics, no? So again, tungod ani nga field, dili lang di ay ang field of power systems engineering ang capable of handling high amounts of voltages and currents. The field of embedded systems. Kinsay familiar ani nga mga device, kaning blue ug kaning green. Kasi nakailaan eh. Is there anyone of you nga kabulon sini sila?
Video card.
Video card? No, not necessarily. Although ang mga video card kay mag-ianam gyapon itsura god na ay printed circuit board. Pero specifically, yes, this is the Arduino, no? And more specific than that, the Arduino Uno. Kailangan magklase Arduino. Arduino Uno. No? And this one, how about the green one? Kasi nakailaan eh. Okay, wala, no? So this is called the Raspberry Pi. Raspberry Pi. 4 man siguro ni siya nga kuan. Raspberry Pi 3 ata ni. So, dagan man pug classic Raspberry Pi. So, these devices or the study of these devices, even this one, this is an FPGA, I think. It's under the field of embedded systems, no? Embedded systems. The Arduino Uno, this one, this component nasa middle part sa Arduino Uno. This is called a microcontroller. Ang sa Raspberry Pi, this one, ang ga-power sa iyaha, this one already is a microprocessor. The same microprocessor, no, not exactly the same, but the same family of microprocessors that are also inside our modern computers, PCs, laptops, no? So the Arduino Uno and Raspberry Pi are not only useful and practical devices, but also helpful in an educational perspective in learning, no, embedded systems. Sige, mabalik siguro ni later, mas sa later slides, no, mas better. Nandito na lang ako na-emphasize on sa sila. So, embedded systems, examples again are microcontrollers, microprocessors, DSPs, FPGAs, ASICs, SOCs. So, yung ASIC. Specific ICs man siya, SOC, systems on chips. Yeah. So, kaninga mga devices and field, dili na kaya siguro ninyo ni ma-cover sa college ninyo, no? Pwede na lang siguro sa microprocessor, magnamoy subject, BSEE, na microprocessors. Yeah. Kaning uban kay mag ECE, intensive na gindi sila, no? At least, sa atong curriculum. Or there's no stopping you from learning man these things. Telecommunications. Siguro kaninga field ang more observable sa atua. Okay? Pag mata pa lang sa buntag, sa atong first nga ginahawiran, di ba? Ang atong smartphone, cellphone, which is capable of connecting, no, not only to the mobile network but also to the internet. So that is under the field of telecommunications. So radio, wireless comm systems, satellite comms, broadcast comms, mobile comms, so tanan comms, communications. Focus lang ko gamay ani, this is an SDR, no? Kanang inyong kakakita karon, I think that is the exact size, no? This is the exact size of an SDR, USB based, no? So what does an SDR do? SDR or software defined radio, kung tanan nato ning first nga figure, most probably this is a broadcasting booth, no? That's composed of different and numerous components and devices, no? Maybe na yung mga pandire, oscillators, filters, broadcast equipment. But now, no, imagine mo sila ito, nga isa ni siya ka laboratory or isa ka room. But now, believe it or not, kanisla tanan, pwede ni sila ma-realize sa inganing kagamay na device, no? Through the technology of software-defined radio, no? Simple lang to akong pagka-state, but it's very possible nowadays. Meaning, we do not need to create our own elaborate radio booth in our home, no? Or separate siguro nga building for us to practice broadcasting, no? Pwede na ay na natay device as small as this USB stick here and dahintay atong own radio receiver, no? Or even transmitter. So those are just some of the most common fields of ECE. Dagan pa, no? Dagan pa diri nga wala gid nako gi appeal because aside sa dito sa common, very specific no kaito sila, no? The field of instrumentation, the field of so mga other subfields. Biomedical, no? Biomedical systems, and so on and so forth. So most of these fields has existed for a very long time na. No? Taon-taon na. Even ang telecoms, magiging siguro yung pinakauna na field na nag-differentiate between EE and ECE, ang field of telecoms. So nowadays, na yung mga modern buzzwords in today's world, no, na very much related sa ECE. One of it is IoT and Industry 4.0. Okay, if makadungogay mo ani, this is where our world is headed, no? Industry 4.0. Before Industry 1.0, ang main technology is the steam engine, no, mechanization. Sa Industry 2.0, electricity, electrification. Industry 3.0, computers, networks, electronics. Sa Industry 4.0, then namusunod ang cyber physical systems, AI, machine learning, IoT, no? Kaning IoT, I think some of you, if not all mangani, have already heard of this one, no? So right now, ang connected lang sa internet are not only us people, but people through smartphones and computers, di ba? Mo pa man ang mga prevalent and mainstream nga way, mainstream nga entities na connected sa internet, no? People and people and their devices, like again, laptops, computers, smartphone. But karon actually nag-start ang IoT, Internet of Things. Not only are the smartphones and laptops connected to the internet, but basically anything in the world nga itong makitaan, pwede na connected sa internet. Wala, di ko slide din, no? Kasi ito nga slide na ko. Cars, no? Sakyanan, pwede na connected sa internet. TV, washing machine, any appliance sa balay, pwede na connected sa internet. As trivial as mug, no? Pwede na siya connected sa internet. Hindi lang ko sure sa gid pwede mabuhat, pero pwede, no? Toaster na connected sa internet, meaning theoretically pwede yung lugar mo nasa somewhere else, and gusto mo nga pagbalik niyo sa balay, kaluto na ang nagawas na inyong toasted bread, no? Pwede nga na IoT nga printer na nakaroon, di ba? Pwede ka mag-print ang printer niyo nasa inyong balay while naamo sa school or naamo sa mall or anywhere, no? So anything right now pwede na connected sa internet. So how about things nga dili built-in ang ilang connectivity to the internet? How will we connect it to the internet? Kumaagian ng mga butang kato ako na-mention earlier. Through the Arduino Uno and through the Raspberry Pi, we could create our own circuits and devices and connect it to the internet, no? Devices like sensors and transducers. No? Kung natay circuit nga kita gid mismo nag-build, no? Not appliances not gadgets, but circuit nga kita gid mismo nag-build. Let's say for example, my circuit could measure the temperature in this room. No? Nagbuhat lugar ko og circuit nga nasa breadboard. So, pwede siya maka-measure sa temperature sa kaning room. So how will I connect it to the internet so that if naman galing ko sa akong office or na ako sa mall, pwede na ako mabalaan if pilang temperature sa balay. No? So I could hook up my device, my circuit, with an Arduino Uno or with a Raspberry Pi. So nahimo na noon siya nga thing na connected sa internet. Okay? So these are just some of the buzzwords na ato ma-encounter in this generation. No? Not only that, also 5G, di ba? I think familiar naman ta. Pero for sure, wala pa kayo takasabot gid sa 5G. Kabalo lang ta na improvement siya sa 4G. So if improvement siya sa 4G, most probably mas paspas ang 5G. Most probably mas nagantag ma-download, no? Ikaw lang ta mag-login sa YouTube, na-load na ang video, no? Most na atong panlantaw sa 5G. And rightly so, that might be correct. But 5G is more than that, no? And dili man noon nato objective karon nga i-define gid ang 5G. That's one topic for another subject. But 5G was not only intended to be faster, but also for multiple things to be connected to the internet. No? So 5G will go together now with IoT and Industry 4.0. For IoT and 4.0 to be possible, kinanglan ma-develop ang 5G. No? So 2018, most probably 2018 na-define ang 5G. So even now, wala pa man kaigid na totally implement ang 5G. So emerging pagyapon siya. Ang 4G gani, even in the year 2017, 2018, napamagani improvements to 4G. Na wala pa fully gid na develop. So ang 5G taon-taon pa ni gamay. So smart car, no? I think we've heard of this kind of car. Nagantag makita niyo sa social media, like the cars that are developed by Tesla, no? So ang atong mga cars karon, are they smart, no? So for you nga dili aware, modern automobiles, even those that were manufactured mga even years prior, even a decade ago, na may mga onboard na computer, na may onboard na microprocessor, microcontroller. No? Taod-taod na, no? It has been a while na ang atong mga sakyanan kay na computer, no? So maybe some of you are aware na computer ang sakyanan. But even if na as a computer, that doesn't make them smart. No? Those computers are there to control the myriad of sensors and actuators na nasa sakyanan. But that doesn't make it smart pa, no? It's not yet smart. What will make a car smart if, again, it will be connected to the internet, no? So slowly develop na nila ning technology. The smart grid, more applicable, applicable din siya sa inyong field, no? Smart grid na system. Maybe when you will be employed as electrical engineers in the future, basit sa inyong generation ni siya ma-fully realize, no? Little na naman ka-exist naman sa gawas. Pero even sa US, di pa magani totally implemented, no? Karon sa Philippines, I think slowly nahihinay naman roll out ni siya nga klaseng technology, smart grid. Again, maybe sa inyong generation in the near future, kani ma-fully realize, no? So gamay lang idea on what a smart grid is. A smart grid is ang electrical system sa balay is pwede na ma-control and monitor sa atong mga electricity providers, no? So gamay lang itong akuan. That's not totally what smart grid systems can do only, but part na siya, no? Unlike karon, no? Example lang, one more observable na application, no? Napamantay mga metermen karon, no? Nagikan sa Sipalco, ato sa balay, mubasa sa atong mga metro nga sa gawas, ano nila pilay bill. Then, pilit lang nila itong papel sa itong gate or asa ba, no? Pag ma-realize na ganyan yung smart grid, wala na siya, no? Dito pa lang daan, makabalo na pila ang makabalo na ang electricity provider pila ang bill sa kada balay, no? No need to send meter readers, and pwede na i-email or i-text ang bill, no? So isa lang na siyang aspects sa smart grid. There are many aspects pa to what a smart grid is capable of doing. Okay, so lahi na po dato atong train of thought to the study of electronic systems, no? So a more systematic approach is required in the study of electronic systems, no? So we define a system basically as this one. No, this will be useful to us as we progress to the semester. So we will define a system as something, no, as a something that manipulates the given input or required input to a desired output, no? So kani nga slide, any system po man ang pwede nato i-use as example ani, no, di pa man sa electronic system. Example, atong sakyanan, no, balik ta sa atong analogy earlier, the car, the automobile. If we will visualize the automobile as a system, kung sa mga inputs, no? So mga inputs sa sakyanan, gasolina, oil, oil ang ginagawa sa sakyanan, hangin, pa, the people, no? We could consider ourselves as inputs to the automobile. And through the user, mga mechanical inputs like pag start sa sakyanan, pag turn sa steering wheel, mapadulong asa na to gusto ang sakyanan, left or right, no? So we could view the car, the automobile, as the system. Pwede gyapon any part of the automobile could be viewed as a system in itself. Example, the engine lang, no? The engine itself is a system already, no? So what is the input of the engine? The input of the engine is gasoline, no, and air, and fuel and air to create combustion. So ang output is ang movement sa pistons, no? So if our system is an engine, so mo to ang input. The input is fuel, no? So ang direct na output lang din sa engine is ang paglihok sa mga pistons. Unless ang atong i-consider ng system is the car itself, no? Which is more complicated kaya daghang makig-input mo atong giingon ganina, daghang kag-input ang car. And daghan siya possible na outputs. Isa sa output is ang pag-move niya from left to right, ang pag-accelerate niya, pag-decelerate, no? So on and so forth. So from this one, it's important no? It's important for us to define the boundary of the system, no? For example, this one, no? What kind of system is this? This is video key system siguro, no? Video key system. The input is sound, the output is sound. Parts sa system ang microphone, parts sa system ang amplifier, parts sa system ang speaker. So meaning ang input is sound, ang output is sound, no? is it correct to say nga ang input ani is electricity, kuryente? Yes. Yeah, pwede. Because naman siya naman siya power supply di ay. Ayun na lang ng kuan. Is it correct to say nga ang yang inputs is ang commands, no, from the user to the push of the button? Yes, kay kung ano man mamaya atong boundary system. Pero let's narrow the system boundary down further, no? What if ang akong boundary lang is ang amplifier lang, no? Amplifier system. The amplifier itself is already a system, no? Ang input is electricity, ang output is electricity or electrical in nature. Is it correct to say na ang input sa atong amplifier is sound? No, no? Ang input sa microphone is sound. But ang input sa amplifier is already electrical signal coming from the microphone. So ang purpose of the microphone is a transducer that converts sound to electricity, no? Dili ba? Mao ang purpose or mao ang use sa microphone, converts sound or sound pressure magina siya technically, converts sound to electrical signal. And kani nga signal din mo ni siya ang i-feed sa atong amplifier. So what's the difference here? No? What's the difference between this one and the slide earlier? Ang system boundary. No? Asa nato gi-bound ang atong system. Because kung asa nato gi-bound ang atong system, mas specifically define unsa pud ang iyang mga possible inputs and possible nature sa outputs. In this case, ang boundary lang is amplifier lang. So we could not expect nga ang output sa amplifier is sound and ang output is also sound. Iyang input is sound and output is sound also. No, we could not expect that from the amplifier. But ang input and output sa amplifier are electrical signals, no? Gamay lang po din nga trivia. When we say amplifier, dili na siya ang katong usay man kung kumain amplifier din matutaw sa mall or sa tindahan. Dili na sa tindahan sa gawas sa kanang mga electronics nga electronic stores. Kumain amplifier is kato na ng dako nga hardware, no? Sir, ma'am, na may amplifier diri so ilang ihatag sa ato is katong mga appliance na, no? Nananagay dito ang speaker. Pero sa atong pag-study sa electronic circuits, ang amplifier lang DI is katong device nga or circuit nga gi-design, no? To use to amplify signal, no? So kung specific nga itsura, an amplifier would look like this. The simplest amplifier could be composed of 4 resistors and a transistor, no? So muna na siya ang amplifier, no? Capacitor, input, output, power. So muna ni siya ang amplifier. Dili part sa amplifier ang microphone, dili part sa amplifier ang speaker, lahi to sila. So again, it's important for us to define the boundary of our system so that we'll know what is the nature of their input and output signals, no? Wait, sorry. Next slide. So if we already define the system boundary, there are different kinds of signal na pwede i-feed sa atong system, especially if that system is an electrical system or an electronic system. So we have analog signals and digital signals. So this is an example of an analog signal, continuous in nature, no? Walay putol, and has an infinite possible values, no? Unlike lugar sa this one, a binary digital signal, duha lang gid nga klase nga values, 1 and 0, or on and off. No? So that's the difference between a binary digital signal and an analog signal. Another example, the engine control unit of an automobile. No? Most probably this is the onboard na computer sa itong mga sakyanan. It is capable of controlling sensors na mo measure sa pressure, temperature, water temp, speed, position, so on and so forth. And yung output is i-control niya ang coil and ang distributor. Even ang distributor, or the distributor is also capable of controlling the spark plugs. No? So, ana. Kaya if atong system boundary ani is taman dire, no? So, yung main output is the control of the spark plugs only. No? So, mo naman yung boundary, oh. Wala. Wala siyang boundary. So, mo na yung mga inputs niya and mo na yung mga output. No? So, those are examples of systems that are not necessarily electronic in nature. So, in the study of electronic systems, we have specific terms for the components na i-connect sa input na side and sa output na side. No? So again, this is the boundary of our electronic system. Okay? We know nga sa kaning side, nasa left part is ang input and nasa right part ang output. So the device na to i-connect sa input is what we call a sensor. No? And sa output is actuator. No? So the sensor and actuator are examples of, or the categories of transducers. No? A transducer is a device that is capable of converting one form of energy to another. No? One form of energy to another form of energy. Wala siyang transducer. So a sensor is a type of transducer that converts any kind of signal, pwede heat, pwede light, pwede mechanical, pwede chemical, or whatever, to electricity. Okay? So from any kind of energy to electricity, sensor. Actuator, bali. From an electrical signal to any type of signal, or maybe back to a mechanical signal, back to a heat or light, actuator na sila. So pwede po na dili necessarily sensors or actuators ang ato i-connect sa system. Anything that is connected to the input side is what we call a source. No? And ang i-connect sa output na side is load. No? You'll be hearing these terms more often from me as we progress through the semester, source and load. Basta source gani, it is that thing that is connected sa input. Basta load, mo to siyang butang na connected sa output. Okay? So kung isa lang ato electronic system, most probably sensor ang i-connect sa input ug actuator connect sa output. Pero pwede pod nga ang atong electronic system is naka-cascade or daghang system ang connected with each other. Example, this one. So we have electronic subsystem A, subsystem B, and subsystem C. Although the main source might be a sensor is connected to A, and the main load, which is an actuator, is connected kay C, no, sa output ni C. Hindi mo tatag example. Ito atong karaoke nga system ganina, no? Microphone. Condenser or speaker. Subsystem A could be an analog digital converter. Subsystem C could be a digital to analog converter. Example lang ni siya. No? Kasi advanced ang atong karaoke system na digital siya. Subsystem B is, say for example, an amplifier. No? So dili tayo necessary nga ang atong source is only the sensor and ang atong load is also the actuator. If we look at the perspective ni subsystem B, again perspective ni subsystem B, unsa iyahang source ug unsa iyang load, no? May maka-guess? Would like to guess? Sa perspective ni subsystem B, unsa iyahang source ug unsa iyang source?
Load ni A, sir? Ay, ang load ni
Si
C,
A.
sir.
Si A. Dili lang kay load ni A, but si A mismo. No? So sakto to. Kung atong tanawon sa perspective ni subsystem B, iyahang source is si A. And iyahang load is si C. Sakto? So si subsystem A, sige, ato na yung A-erase. What if ang atong perspective now, ang atong system in question, ang atong ginasadihan, is si subsystem A. Iyahang source, isang atong main nga source, which is the sensor. But iyahang load is not our speaker. Ang load ni subsystem A or ang load ni analog to digital converter is si subsystem B. No? That's why nabitaw dito ka-label, no? Si subsystem B is load siya sa perspective ni subsystem A. Si subsystem B is source siya with respect ni subsystem C. No? So on and so forth. Again, why is this important? This is important because ma-define na to unsa ang sources and loads sa isa ka specific na system, no? Maybe source po na siya or load po na siya sa isa ka system after it or preceding it, no? Later, much later man good, no? After midterm siguro, there is such thing as we call input impedance, output impedance, and gain, no? Voltage gain. And if any of these systems has these parameters, pwede man good nga ang load ni subsystem B is ang input impedance ni subsystem C. No? So silang, ay lang kayo na siya i-absorb. No? Balik na tana later. So the point is, si main source and si main load are only the sources and loads of the systems connected to it. No? And if na yung mga middle systems, ang iyang sources and loads is iyang mga neighboring nga mga subsystems pod. Okay? So in summary, no? Or maybe we could also look at the study of electronics in this way. No? The study of electronics is the conversion of a more practical problem to a physical problem or problem that requires physics, no? Physical problem. No? Example, what is an example of a more practical problem? Sige. long distance communication, no? Ever since mo gid ni ang akaw na solve na magud ni. Ever since mo gid ni ang mga gusto sa tao, no? Gusto sa mankind for long distance communication. Kita mo sa mga salida, sa mga salida, ang very crude form of long distance communication is magbuhat sa bonfire, no? Mga cavemen siguro ganyan eh, buhat sa bonfire, then tabunan nila o habol or whatever, then mag-accumulate mo na og smoke, then ilahang i-release ang smoke, no? Mag-addo din sa air ang aso para mailahan nga naalis na dito, no? So that's one example of a very primitive long distance communication, but it's still long distance nonetheless, no? Long distance magina siya. So as the centuries pass, mankind has developed ways of long distance communication, no? Using electrical cables and Morse code. No? Muna sa una, Morse code. So kana sigurong idea nga face-to-face communication, face-to-face nga long distance communication nga makita gini mo ang dagway sa imong kasturya, basin para sa ilaha magical na kaina, pero look at where we are right now. Oh. The same sa kanang kahitabo karon, oh. You could see my face. Kung i-turn on niyo yung camera, I could see your faces, di ba? So how is that? No, how is that possible? That's possible because of electronics, because of the because of the developments in the technology in the field of electronics. No, it has reduced the physical problem. No, sorry. It has reduced the more practical problem. No, of the need for long distance communication into a problem in the domain of physics. No, so what is it the eye in the domain of physics? No, dili ba sa kaning stage ang electricity, the flow of electrons, magnetism, kaning mga phenomenon, di ba? Electromagnetism, no? Light, chemicals, di ba sa kanini siya nga field under, no? Electricity, electrons, electromagnetism. So as we ascend sa atong ladder, one step further is how will we manipulate electricity, the flow of electrons, electromagnetic fields through electrical devices such as diodes and transistors. So diodes and transistors, ibali, are those things that are capable of manipulating or controlling physical phenomenon. No? But diodes and transistors in themselves are not enough for telecommunication, di ba? Long distance telecommunication, di lang binasa enough. No? They are just the second step sa ladder pa. So a step further are analog circuits. Okay, analog circuits such as amplifiers, filters, oscillators, modern telecommunication systems, no, computers, tanan nga involved ani nga pag-solve sa problem of long distance communication has inside of them amplifiers, filters, oscillators, and many more analog circuits. And these amplifiers, filters, oscillators are composed of diodes, transistors, inductors, capacitors, so on and so forth. One step further are digital circuits, kato, such as gates, latches, and timers, etc. Another step further is digital logic, no? So pag-organize, pasok mo ng architecture. So pag-organize ani nga mga concepts, no? Like Others, ALUs, arithmetic logic unit. Sige, ay lang ni take note no, di pag-usong mga words kay mo nga mga devices good under ani nga leg. Pero sige lang. Okay na dili niyo take note. Others, ALUs, registers, counters, na. Next is microarchitecture, no? Kani medyo abstract na kani sa ato karon, no? Ay lang kay ninyo serious good. Kasi magawas sa atong mga ilong. So microarchitecture is the organization of the hardware that will be used to build a microprocessor, no? Microarchitecture, the architecture of microprocessors. Then architecture, this actually is, or more formally, computer architecture, no? How computers are built, which define the operating system, no, of computers, no? So operating system, we have Windows, diba? Mac, Linux, etc. No? So before we go further, try to be in the perspective of software developers or programmers in this area, operating systems. Dili na sila necessarily ga-study ang ga-study ng operating system, sa di sila necessarily ga-study ug all this stuff nga nasa ilalom pa sa ilaha, no? As long as they know how to program, they could create operating systems. So munang advantage to this concept, no? Ma-restrict lang ang study sa isa ka branch. Ma-restrict lang ang pag-study sa isa ka branch, sa kana lang ang pod nga level. And last but not the least is software applications, no? So in this area or in this leg, we now have Zoom, kanya itong ginagamit, Facebook, Messenger, etc., Google Meet, no? So pamagi sa Zoom, pamagi sa internet, pamagi sa Zoom, pamagi sa Facebook, pamagi sa browser, we are now capable of realizing long distance real-time pagyod gani, no? Real-time communication, no? So kana nga path ang gitake to convert the practical problem of long distance communication to a more physical problem of manipulating electrons, no? So atog yung hunaon ug maayo, ang long distance communication di ay is just the manipulation of electrons. Simple lang ganyan siya para-define, pero that's true, no? So like kaning inyong kakakita karon, no? Kakakita sa inyong screen. Technically dili na maginako na dagway, but that's just a recreation of my face through, again, the manipulation of electrons, no? So from the domain of physics to the domain of software engineering, the creation of software like Zoom and Google Meet. Okay? So kita, electronics, ECE 12.1 is kanilang subfield. ECE 12.1 na lang diha, no? Kanitanan taman sa architecture is gina-study sa mga ECE, no? ECE 15, ECE 18, ECE 20, na. So kita sa 12.1 dili lang tataman the study of devices. Apil pa din niyo? Sorry. Apil pa din ni. Covered pa din ang kaning no, sa ato ang curriculum sa atong syllabus. Not only the study of devices, but the study of circuits. Diodes, transistors, amplifiers, filters, oscillators. We won't necessarily build digital circuits. We won't, of course, study operating systems. And of course we will not build software here. We'll only study the devices and analog circuits that are needed for practical applications. So the study of electronics entails knowing resistors, transformers, inductors, and basic passive circuits, voltage dividers. So what differentiates an electronic circuit from a purely electrical circuit? The presence of discrete active components such as these ones, diodes and transistors. Sometimes thyristors. Okay. Pagka na gani nga circuit, electrical circuit, na isa lang ka diode, electronic circuit na siya. Kinaay, nag-exist nga diode ang circuit. If ang voltage divider circuit, like such as this one, no? Sakto ba? This is a voltage divider. Sige, ka balihin na. This is a voltage divider circuit, right? No? Kani? You've encountered this one sa circuits 1 ninyo. And that's a purely electrical circuit. But if tungaga na to na siya isa ka device called a transistor, no? And magbutang lang dayon ta dili og mga additional resistors. Electronic circuit na dayon. And this one is our very basic amplifier, no? Yan na day ka simple ang pagbuhat og amplifier. Voltage divider lang ang resistor network, and then transistor. No? So we might not necessarily include these components. If natay time, pwede, no? Pwede na ito niagian. Puhon. Napatay extra time. Pero mas mag-focus lang kita dire. No? Diodes and transistors. No? At least maset na itong mind. No? Diodes and transistors. There are two types of transistors. We have the BJT, bipolar junction transistor, and the FET, or FET, field effect transistor. Na po isa nga wala dire, important gyapon, no? Malag maapil pa nato gani op amp or the operational amplifier. No, appeal din na siya sa ECE 12.1. So when we say electronic devices sa ECE 12.1, ang devices dito are not gadgets and electronic systems, but electronic devices such as diodes, transistors, and op-amps. Kanang three, mo gid ang pinaka foundational na devices. So sa circuits pa, resistors, resistors, inductors, capacitor. Sa ECE 12.1, diodes, transistors, and op-amps. Okay. So kung gusto mo mag-read ahead ng mga multiple sources, focus lang mo ani, diodes, transistors, and op-amps. Okay. So I guess that's it. No? That ends my presentation on the introduction to the field of ECE and the study of electronic systems. Any questions?